Assalamualaikum. My name is Fatin Fadhilah binti Tugiman. So this video is present about my final year project. The title is the simulation of longitudinal and lateral vehicle motion in double and change maneuver. And I would like to say thank you to my supervisor, Dr. Rashid, where he is guide me from the start of this project until the end. This project is focused about the double and change maneuver. The double and change is one of the most common driving maneuvers. Drivers must be able to make decisions and plan well in order to make a safe double and change. By using a software which is MATLAB Simulink, the simulation of double and change test under ISO 38882, it will be used to investigate the effect of vehicle speed and longitudinal distance in order to avoid obstacles. This kind of maneuver will give a high risk if the driver cannot plan well in order to change the lane. In a sudden lane change situation with a small gap between the cars to be cut off, it can be fatal. If the driver uses the emergency brake during high speeds, it will be very risky. The objective of this project is to investigate the effect of vehicle speed in double and change maneuver by using a MATLAB Simulink. And another one is to find the effect of longitudinal distance in double and change also by using a MATLAB Simulink. For project scope, a full vehicle dynamics model is used in MATLAB Simulink, and then set up the vehicle model's parameters such as inertial longitudinal position of gate entrance, time, vehicle width, and longitudinal entrance velocity set point. As for the literature review part, it is about the degree of freedom of full vehicle model. Degree of freedom is it will associate with vehicle dynamics to handling a vehicle. The higher the number of parameters or degree of freedom, it is better than models with lesser parameters. As a disadvantage, when use a higher degree of freedom model, it will require more data and time to solve it. Automotive researchers use it to focus on applying a full vehicle model with equation which include the right vehicle model and the handling mode. Okay, next literature review is about a double lane change. Many researchers have undergone lane change according to the standard ISO. One of the double lane change tests that has been conducted is to investigate vehicle motion between Adam's car model and chrono vehicles, where chrono vehicle is a template-based modeling toolkit for chrono engine. And this is the result of simulation by the author. Found that from the simulation test, both results for the two different models are slightly closer for the double and change under ISO standard. For the methodology part, for the first week, briefing of PSM by Mr. Low, and next, after we know the title of the project, identify the problem statement, and then do a literature review from the previous researcher, and then use a reference model of double and change maneuver in a MATLAB Simulink software. And after we have used a reference model, we check for the parameter and set up the value according to the table 3.1. After we set up the parameter, we run the simulations, and then The result of the simulation will be discussed and finally do a project report. This is the velocity versus time result of the double and change test. After it reached the maximum speed, the vehicle maintained the speed without lower the gear until it entered the gate entrance. The vehicle start to lower the speed of vehicle in order to change lane. And then to enter the left lane, the vehicle speed maintained again. After enter the gate entrance, it slow down the vehicle again. And at this stage, the vehicle back to the original lane. For acceleration versus time graph, both graph has respond at 1 second because that time the vehicle start to maneuver. For result on the test 1, it is clearly show that the difference between two peaks is broader. This indicates to the maximum speed for the test 1 is lower than the test 2, which is 30 miles per hour. So it is a bit slower to accelerate the vehicle. The result for engine speed versus time of the test showed that difference between the peak for the test 1 and test 2. There are 3 obvious peaks on the test 1, while for the test 2, there are 4 obvious peaks. The existence of the peak number 4 on the test 2 is because the driver changed to the highest gear. This is for the vehicle reach the maximum speed, which is 35 miles per hour. And also, for the test 2, it is showed that the graph is going upwards after 15 seconds. This is because the car start to shifting into a lower gear, causes the engine to move more faster. So the engine speed increase. For the steering wheel angle versus time graph, the difference between test 1 and test 2 are at the middle peak of the graph. The broader difference between a peak on the test 1 because the maximum speed is not too high as the test 2, so the steering wheel only steer at the lowest degree, not like on the test 2 where the degree of the steering wheel angle is too high. And also for both graph shows up and down and also flat peaks. This is because the common input from the steering. Overall, from the results that I obtained from the simulation test, it can be seen that for the test 2 graph, the curve on the peak is smoother than the test 1. And overall for the all tests, for the gate entry distance in 175 meter, it has the longest time taken to make double and change compared to the other gate entry distance. And this is for the smoother curve. This is because the pattern of transition is highly influenced by the system, whether it is a quick or slow response to a driver. And with the slowly reacting systems, on the other hand, it will show a progressive alteration in ecological status over time. And this is the reason why the graph for the test 2 is smoother than graph at test 1. And the line for the 58 meter and 88 meter of gate entry under test 2, it has a small gap compared to the result on test 1. This is because at high speeds, a low force at the steering wheel can immediately increase the steering angle. And in contrast, the steering wheel at a low speed, the driver must press harder on the steering wheel. So that means it required a more force to lower the speed as we push the brake pedal. In a nutshell, the double lane change test was done and presented in this project to validate the effect of the speed and the longitudinal distance in order to investigate the longitudinal and lateral vehicle motion. And all the tests are satisfactory, demonstrating longitudinal and lateral vehicle motion during the double lane change maneuver. All the parameter tests valid under ISO 38882. By using the reference model of double lane change in MATLAB Simulink, it can be used to conduct vehicle research for the future. Real driver parameters also can be identified using the optimization procedure. The double lane change maneuver is one of the most basic driving maneuver. This kind of maneuver can reduce risk if the driver provides the appropriate input during the move. Even the simulation for all double lane change maneuver tests gives a good result performance. It is still need to improve of the current research work as it is for the better result for future studies. For the first one, we can use another software like CarSim that can be as an alternative for real situations. The simulations by using software, it can reduce time consuming and more safer than do the test on the road. And next, the result of double lane change test can be improved if setting up the controller inside the controller block set of the double lane change reference model. This is for the to analyze on how far it will increase the performance of the maneuvering if compared to the default setting. Lastly, it is recommended to use variety of weight value in order to investigate the performance of double lane change maneuver between passenger car and commercial car. This can be used by setting up the value on the maneuver parameter and the lane change reference generator block set. That's all from me. Thank you.